This is lesson 32, dealing with square roots and how we rationalize them when they're in a fraction, okay? So thus far, we've known that the square root, if both of these numbers, 3 times 2, were under the square root sign, we could say that's the same thing as the square root of 3 times the square root of 2, right? In the same way, if we have this as a fraction, the square root of a fraction, that's the same thing as the square root of 3 over the square root of 2. And we can then rationalize this by multiplying, which is what we've already learned, by the square root of 2 over the square root of 2. That equals the square root of 6. You multiply the numbers under the radical sign. The square root of 2 times the square root of 2 is 2. Okay? So you simplify it by multiplying by the denominator over itself. Okay? All right, look at problem 32-1. Example problem 32-1. This problem is the square root of 3 over 7. That is the same thing as saying the square root of 3 over the square root of 7. And I can rationalize that by multiplying by the denominator in the numerator over itself. And I can multiply the numbers under the radical sign. That's square root of 21. Square root of 7 times the square root of 7 is 7. And this is your answer. Okay? Now, what if I am adding two irrational fractions? How do I handle that? Well, I'm going to rationalize both terms. Look at 32-2. If I have the square root of 2 over 5 plus the square root of 5 over 2. That's the same thing as saying the square root of 2 over the square root of 5 plus square root of 5 over the square root of 2. I will rationalize the denominator of the first term by multiplying the square root of 5 over the square root of 5, and the second term by multiplying by the square root of 2 over the square root of 2. 5 times 2 is the square root of 10 over 5, plus the square root of 5 times 2 is the square root of 10 over 2. Now I have to find a common denominator, right? There's no equal sign, so I must find a common denominator. This one, I would multiply by 2 over 2 because my common denominator is going to be 10. Okay? This one, I would multiply by 5 over 5. Okay? I'm not going to leave it at this point. I'm going to find a common denominator and combine my numerators. Okay, 2 times the square root of 10 is 2 times the square root of 10 over 10. 2 times 5. Plus 5 times the square root of 10 over 10, which is 2 times 5. Now I can combine my numerators and call it 2 times the square root of 10 plus 5 times the square root of 10 over 10. Okay, these are now like terms because I have the same radical. So I can add my 2 and my 5. So that is going to equal 7 times the square root of 10 over 10. And if you get to this point, because 7 is multiplied by the square root of 10, if this could be reduced, say if this were 8 times the square root of 10 over 10, I could reduce my 8 and my 10. Okay? Does this make sense? Yes? Okay. The latter part of the chapter is on congruence, which we will not do. Yay. Like side, angle, side, angle. You guys remember all of that, right? But if you do have congruent triangles, in the same way we have been, God bless you, in the same way we have been looking at corresponding sides, we can also look at corresponding angles, can't we? Let's do sample problem C. Actually, practice problem C. Okay? Yes, corresponding parts of congruent triangles are equal, and the geometry class will need to know that today for their test. Okay, sample problem, practice problem C on page 149. Let's work it. Okay? We have two sets of parallel lines indicated by the arrow. 4x minus 1, 4. 4x plus 1, 12x minus 7, p, and 4. Okay? It says the two triangles shown here are similar by angle, angle, angle. Obviously, that's the only way they're similar, right? Two corresponding sides have the length of 4. Okay? So let's write our corresponding sides. This side corresponds to this side. Okay? And the scale factor is 1. Obviously, 1 to 1. Got it? Because 4 equals 4. Okay? Find x, then find p. Okay? If 4 is to 4, then what side, if I look at this side, what side does this equal? The 12x minus 7. That is its corresponding side, right? And if I look at this one, 4x minus 1, that corresponds to p, right? So now I can look at this equation and I can solve for x, okay? So I have 4x plus 1 equals 12x minus 7. Let's move our 7 to the other side. And that way I'll end up with all positives, right? So I have 4x plus 8 equals 12x. Those cancel out. I'll move my 4x with my 12x, and I have 8 equals 8x. How easy is this? Divide by 8 on both sides. X equals 1. Got it? Now we know what x is. Now I can plug in x here and solve for p. 4 times 1 minus 1 equals p. What's 4 minus 1? What does p equal? 3. P equals 3. Okay?